Hey guys! Alright, so today we are talking about theoretical and experimental probability. So, I want you to write at the top of your notes, keep in mind that our next quiz will be Friday, October 24th. You will be quizzed over this material right here. So our essential question is, what is theoretical and experimental probability? So, what is theoretical probability? Well, that is just what should happen in an event. And guess what? This is actually what you've been focusing on for the past 2 weeks. All of these probability problems that you've already solved have to do with theoretical probability. You're just writing down what should happen in an event, and that means it's the number of outcomes wanted over the number of total outcomes. So what's new here? Well, that would be experimental probability. Experimental probability is what actually happens in an event. So that means you're actually performing the action. So if we're talking about flipping a coin, let's say you flip a coin 4 times. Well, theoretically, it would land on heads 2 times, and it would land on tails 2 times. But if you perform an experiment, it might land on heads 1 time, and it might land on tails the other 3 times. So in experimental probability, you're writing down the number of times event E occurs. An event E is just whatever you want to happen. So let's say tails. So in my example, I said it landed on tails 3 times. So you would say 3 out of the total number of occurrences, which would be 4. For your experimental probability, you will be given data, or you will be generating it based on the experiment you are performing. And whenever you're performing experiments, you will have to make a prediction. And a prediction is just a reasonable guess of the outcome. You will be practicing with that later in the week. So let's go ahead and do an example together. And I'm going to zoom in on this. Alright. So, it says the following are results of rolling a die 20 times. So, here's our chart right here. Here are all of the numbers we see on a die. Each X represents how many times that number was landed on. So the number 1 was landed on 4 times, 2 was landed on 2 times, and so on. So we want to know, what is the theoretical probability of rolling 6? Well, we know theoretical means what should happen, and this is what you've been doing for the past 2 weeks. So we have to think, okay, how many sides of a die contain the number 6? Well, that would just be one side. So that would be 1. And then how many total sides does a die have? Well, that would be 6. So the probability of rolling a 6, the theoretical probability, would just be 1 over 6. But now we want to know, what is the experimental probability of rolling a 6? So to figure that out, we have to look over here at our data. So now we have to see how many times it actually landed on 6. Well, that would be 1, 2, 3, 4 times. So it landed on 6 4 times. And we know that we rolled it 20 total times. So our denominator is 20. So we get 4 over 20. And then we just reduce by dividing by 4 on top and bottom. 4 divided by 4 is 1. And 20 divided by 4 is 5. So in this experiment, the experimental probability of rolling a 6 is 1 out of 5. As you can see, the experimental probability does not always match up with the theoretical probability. So the experiment does not always match what should happen. Okay. I want you to pause the video and try this section on your own. Let me zoom out just a bit for you. So before you pause, it says the following are results of spinning the spinner 30 times. So here's your data. This was spun 30 times, and this is telling you how many times each letter was landed on. Go ahead and review that, and then I want you to pause the video and answer questions 1 and 2 on your own. Okay, so number 1 says, what is the theoretical probability of spinning C? So we just want to know what should happen. Well, over here, we have one section of the spinner that has the letter C on it. So that's one section out of 4 total. And I know this picture is not perfect, but we are pretending like these are perfectly equal sections. So the theoretical probability of spinning a C is 1 out of 4. Now we want to see, what is the experimental probability of spinning C? Well, let's see how many times it actually landed on C. 1, 2, 3, 4, 5, 6, 7, 8 times. So it landed on C 8 times. And we know from this data here that we spun it a total of 30 times. So it landed on C 8 out of 30 times. As always, I have to simplify and reduce. I can divide both of these numbers by 2. 8 divided by 2 is 4. 30 divided by 2 is 15. So the experimental probability of spinning a C would be 4 over 15. Make sure you have filled everything in. Make sure you're prepared to go over this in class on Monday and perform some experiments yourself. Have a good weekend. I'll see you on Monday.